The 9060 XT is launching today, and I have the ASUS Prime version of the 9060 XT. At $349, well, starting at $349. The pricing is going to be a little different in retail, as it always is, because the world is on fire. But 16 gigabytes of VRAM, pretty reasonable performance. Let's break it down. Let's take a look. Alright, if you missed the AMD press release, this thing has some pretty cool features on paper. It has 32 RDNA 4 compute units, 32 hardware ray tracing accelerators, 64 hardware AI accelerators, 821 peak AI tops, 3.1 gigahertz boost clock. It's going to be available in 8 and 16 gigabyte varieties. Though I'm going to heavily recommend the 16 gigabyte variety for more GPU longevity. If you like to hang on to your card for a long time, you're going to 16 gigs. Like, the compute resources on this card can take advantage of 16 gigabytes of VRAM. That hasn't always been true. You know, sometimes companies will launch a card that has like 12 or 16 gigs of VRAM, but then the compute resources on the card will never be able to use that to just try to satisfy some sort of weird marketing thing, but it's part of planned obsolescence. Whereas this card is actually fast enough to use 16 gigs of VRAM, so you should probably stick to 16 gigs of VRAM. But there is an 8 gig version that's a little cheaper. But 16 gigs. It's PCIe Gen 5, 16 lanes of connectivity. That does help a little bit if you go the 8 gig route in terms of like being able to load textures into the cards. So, it has 2 DisplayPort 2.1a, that's UHBR 13.5, we'll talk more about that, and HDMI 2.1b, so only 3 outputs instead of 4. So there's a little bit of a reduction there. In terms of an upgrade over the RX 7600, 7600 XT, this is a significant, shocking even, upgrade over the 7600 XT. AMD has really outdone themselves. In terms of placement in the market, we'll talk more about that. But first, let's talk a little bit more about the board power. So 150 to 180 watts, 160 to 180 watts is the configuration. I have several of these. I have content planned around several versions of the 9060 XT, which vary the board power a little bit. And so stay tuned for that content in the next couple of days, because it is more interesting than it usually is in terms of performance differences that makes in various versions of the 9060 XT that are going to enter the market. So stay tuned for that. But yes, this one is kind of a baseline configuration, or not exactly a baseline configuration. I mean, we do have like the little OC edition sticker here from ASUS, and ASUS has done some special sauce here to squeeze as much performance as possible out of the 16 gig 9060 XT, and we'll see that in the gaming benchmarks. But understand the base configuration for this card is 160 watts and 2.53 gigahertz GPU game clock and up to a 3.13 gigahertz boost clock. That's sort of the baseline. But ASUS has, OC edition. There's a little bit of an overclock there. Seeing boosts up to 3.3 gigahertz on this platform. So, and you can see that in the game performance benchmarks as well. Let's start with our artificial benchmarks. Let's start with Geekbench, OpenCL specifically. And let's see how this stacks up against the 4070 Founders Edition. It only has 12 gigs of VRAM, keep in mind, as we look at these comparisons, because the 4070 is great until it runs out of VRAM. 12 gigs is pretty good, though, for 1080p and 1440p gaming, which is where this card is aimed. The ASUS 5060 Ti Prime, 16 gigs, those are coming in pretty awesome. The 9060 XT Prime here, it's looking better than the Intel Arc B580, but we're not off to a super amazing start here with OpenCL. The Vulkan benchmark also was kind of surprising. The 9060 XT is bringing up the rear of the pack. Vulkan is I don't understand, because when we take a look at games like Doom Eternal, these things run great. So what's going on? We'll talk more about that. 3D Mark Port Royal. Well, the 9060 XT is giving the 5060 Ti Prime a run for its money. And keep in mind, at retail anyway, the 9060 is significantly less expensive than the 5060 Ti Prime. I mean, the NVIDIA cards are carrying a premium. Like, they cost more MSRP, but then actually when you go to try to buy one at Micro Center or Newegg or wherever, they're significantly more expensive. They may vary in your market, but, engage below. What's going through your mind? What are you considering when considering a GPU? Is the Intel B580 even on your radar. I wanted to include the B580 for a few selected games and to share my gaming experiences, but I'm sort of curious about your thoughts. I mean, is like the 5060 Ti, like, okay, there's a 5060, and then, yeah, I don't know, the MSRP is like, oh, it looks like it's only slightly more expensive, but the reality is that it's significantly more expensive. It also only has 8 gigs of RAM when it's only slightly more expensive, and when it's significantly more expensive, it's 16 gigs of RAM. So I don't know. Try to test 16 gig for 16 gig here, except for the B580, of course, which is 12 gig, and the 4070 Founders Edition, which is also 12 gig. But I've tried to do like for like as much as possible. What about Time Spy? How does Time Spy look? This is looking pretty good. The 9060 XT is ahead of the 5060 Ti Prime and just a little behind the 4070 Founders Edition. The card is looking promising. And this is really good when you consider that our 128-bit memory bus in the memory configuration here has a lower fill rate and a lower peak bandwidth than is possible with the 5060 Ti. So AMD is really doing some magic under the hood here to take every advantage of what hardware resources they have. Firestrike has the 9060 just a little behind the 5060 Ti and a little behind the 4070 Founders Edition. I think this is really interesting given the price point and the positioning of this card in the market. This is a good result for the 9060 XT, I think. Day 2, right? Performance analysis. I changed shirts because time has passed. No, I had a little trouble benchmarking because of Windows Update and some other anomalies, which I'll talk about. So let's start with Shadow of the Tomb Raider. This is an ancient game. It is almost becoming irrelevant to test with modern cards, but this does give us a nice baseline for raster performance. I mean, okay, yeah, it has a little bit of ray trace shadows, but the ray tracing is so easy that it really shouldn't count for anything. These are pretty solid results. 175 FPS for our 1% lows, 218 FPS overall. This is a good result for this card given its price point. Now, if we step up to 1440p on the high preset, we're still getting 140 FPS. This is also a thing that I want to call out with modern GPUs is that it's non-linear scaling a lot of the time, meaning that 1440p, for the proportion more pixels that is, the performance fall off is not as significant as it has been in prior generations. The performance at 1080p doesn't necessarily indicate the performance that you would have at 1440p if you're just doing pixel counting, which is how, we used to look at it and estimate performance. 140 FPS is really solid here for this card. Also want to take a look at Assassin's Creed Shadows because this game exhibits some behavior that I saw in several other games that is like there's kind of a spectrum of performance here when we're talking about the drivers and the experience. And also it's really hard to do a true apples to apples comparison. That is literally just frame generation off native performance. But actually playing the game and enjoying the game on a high refresh OLED display, there is something to be said for that. This game, I was having a blast with 4X frame gen on a 5090 in Cyberpunk and Assassin's Creed and a bunch of other games. Buttery smooth, amazing goodness. Butter for your eyes in terms of the pixel refresh and also the visual fidelity in the game. It's a lot of fun. The 5060 Ti multi-frame gen is not a good experience in Assassin's Creed for whatever reason. And there are other games that are like this, but this is a 1080p high. And yeah, look, top line number, 189 FPS, 45 FPS. This thing was a juddery mess in real world gameplay and just messing around in the game. Not a lot of fun. Single frame gen was a completely different experience on the 5060 Ti. And it was also a pretty good experience on all 4 of the cards that I'm testing here. And of course, our native frame gen off performance, not bad. I mean, 34 FPS for our 1% lows, 63 FPS average. And this is on the high preset. Now, if you want to back that off a little bit, you'll get a lot better performance. But this is a pretty good result for our 9060 XT Prime here. I wish it was a little better, but this isn't a bad result. And this sort of This game, I think, is a good example of if you use reasonable settings, you can have a reasonable gameplay experience. And that's true whether it's Team Green or Team Blue. But I think Team Green tripping over its own shoelaces to try to say that multi-frame gen is the end-all be-all, at least in this one particular game, is not an enjoyable experience with the 5060 Ti on these graphical fidelity settings. Now, if I mess around in the settings, can I get a better experience? Can I get my 1% lows number up a little higher? Yes, absolutely. But multi-frame gen is basically a smoothing technology, and it helps when you have a much higher refresh display. I think that it makes sense if you're base frame rate is in the neighborhood of like 60 to 90, okay, maybe. But single frame gen, for whatever reason, is a little better. Like, I wouldn't think that the 1% lows would be, 45 to 50 FPS. It's like 5 FPS difference. I guess it's trying to juggle multi-frame gen. I don't know. That's not a huge difference. But the 9060 XT Prime does a lot better job in the 1X frame gen, and, with all there's scaling and some other stuff there too, I guess, going on. But real world, what I'm telling you is that all 4 of these cards can give you a good experience in Assassin's Creed, but you would also be crazy to look at the multi-frame gen number if you had a 5060 Ti and say that this card is dramatically way better, because real world, my opinion, playing the game, not actually. Now, what if we step it up to 1440p? This is a little bit of that non-linear fall off that I'm talking about. This is much better visual fidelity at 1440p, and it was still a great gameplay experience. Now, with frame gen off and everything running at native, I would have hoped for a higher frame rate. But I would have hoped for a higher frame rate basically across all of our cards. Cyberpunk is really similar to Assassin's Creed, although it's not as egregious, because I think it's gotten a lot more tuning and people have really returned to enjoy Cyberpunk. So let's take a look at Cyberpunk without ray tracing at 1080p first. This is 1080 with the high preset, no ray tracing, and I think it defaults to FSR quality on this preset. So the 5060 Ti with 4X frame gen, 400 FPS, but again, 89 FPS. Now, the judder and weirdness here was a lot less noticeable in Cyberpunk than Assassin's Creed, for whatever reason. And I don't think that was down to just frame rate numbers. Might have been Windows Update related. We're going to complain about that in a little bit. It turned Indiana Jones into just a crater of a smoldering gaming experience. But we'll talk about that when I get to Indiana Jones and the Great Circle. The frame generation on 1X was a pretty good experience across all 4 cards. The 9060 XT is doing pretty well here, I think. I wish the 1% lows were a little higher. There's something going on with the 1% lows with a Windows update. So when I first did this, the 1% lows were a lot lower, and it turned out that the culprit for this was this Windows update, which is supposed to solve NVIDIA driver issues. This Windows update was also responsible for problems that I've been alluding to with Indiana Jones and the Great Circle, which we'll talk a little bit more about. But still, even after rectifying that in Cyberpunk, in real-world gameplay, for whatever reason, our 1% lows were a little lower than our other 3 cards. Now, I didn't really notice it in like triggering explosions and doing all sorts of stuff like that at this resolution, but at a higher resolution, I did notice it, and we'll talk a little bit about that. So let's step up to 1440p. 1440p on the high preset, no ray tracing with FSR quality. Again, this is a pretty good gameplay experience across all 4 cards. And here the 9060 XT is standing out with its 1% lows. It's doing a better job than the 9070 FE and the 5060 Ti. And again, this may be related to NVIDIA's driver problems that they've had. Even the B850 is doing a better job here with their 1% lows. And the gaming experience with all 4 of these cards, to be sure, like nothing was terrible. With frame gen off, the stack here looks about like I would expect. The 9060 XT really is holding its own. It's doing a good job. And 4X frame gen, while it's a thing, it was not as bad as Assassin's Creed, but if I had a 5060 Ti, I would not be playing with 4X frame gen on Cyberpunk at 1440p. Like, sorry. That's a me thing. I'm just letting you know. Now, what about a 1080p with ray tracing? Well, again, frame gen, 4X frame gen, but single frame gen and native performance here was pretty good. Native was a little worrying because the 9060 XT, this is also one of the first games that I test, and I worry it's like, oh, did AMD cut back the resources for ray tracing too far? Is that why this game is struggling a little bit with the medium preset and ray tracing? But our 1% low dips here seem to be explosion related. Like if I do something that caused a lot of cars to blow up or just like running through my test circuit and there's a lot of explosions and particle effects, that seems to be what drags down our 1% lows at native. But with a little bit of FSR, the problem goes away. I don't know. This is maybe something that will be up. It just depends on your gameplay style. The subjective experience on all 4 of these cards with frame gen off is that it's all reasonable and it's all pretty playable, in my opinion. I think we have to step it up to 1440p to see if this is going to make a meaningful difference. So the 1440p high preset with ray tracing on and FSR quality, yeah, the performance here is not as good as I would have hoped on the 9060 XT. But again, it's non-linear scaling. We're basically at similar performance to 1080p. At the native resolution on all four of these cards at 1440p, it is not as good of an experience as I would want. With FrameGen on, it's a better experience with all four of these cards, or if you turn down the fidelity or you change the resolution scaling, it's a better overall gameplay experience. This is also the one where multi-FrameGen really falls apart the most with the 5060 Ti. So again, if you have a card that's that far down the stack, multi-frame gen I think is less important. Like, that's the thesis, that's the thing that I'm coming to, is like, if you have a really high-end card and a really high refresh rate display, multi-frame gen can be a lot of fun. But I'm very, after working on this review for this card, I'm very sus of multi-frame gen at lower ends of the stack. I'll just say that. That's enough beating of that particular horse. The results for Monster Hunter Wilds at 1080p high with native resolution were pretty good. Like, if you look at the breakdown here with Monster Hunter Wilds in our high native non-ray tracing configuration, 1080p and 1440p performance is very, very good with this game. It's a really good overall experience. It's maybe at the opposite end of the spectrum as compared with Assassin's Creed and then Cyberpunk. And here the ray tracing result is also curiously impressive. If you look at things struggling a little bit at 1440p with medium in Cyberpunk, it's like, okay, I'm going to have to rely on FSR in order to have a good ray tracing experience. Monster Hunter, that's much less true. Even at 1440p, if we step it up to 1440p and we look at our numbers here for ray tracing, these are really good numbers for the 9060 XT. Now, Indiana Jones and the Great Circle. The aforementioned Windows update and the aforementioned NVIDIA drivers, which I think are meant to address some of the black screen and driver rough edges that NVIDIA has been experiencing. What a crazy world we live in, where AMD doing all of this fun stuff with FSR and HyperRX and Adrenalin, and making it so that you can just launch the Adrenalin software, click a few buttons, and get optimal settings for your games, which, by the way, works really well with all of these games. When I say that you can basically play any modern title at 1080p or 1440p, Adrenalin can help you find those settings for your game and deploy it, and you will have a pretty reasonable gameplay experience as long as your game settings are reasonable. It's like the old meme from a long time ago. It's like, can it run Crysis? It's like, yes, it can run Crysis just fine. It can run Crysis even on Ultra. But if you are going to try to set it at some absurd, ridiculous thing, then yeah, okay, this is a down stack card. I mean, come on. Indiana Jones is one of those games that it's got ray tracing. You can't turn it off. And 6,000 and 7,000 series AMD cards struggle with that because the weakest point of 6,000 and 7,000 series AMD cards was ray tracing. Ray tracing is kind of in vogue now in a whole bunch of games, and Indiana Jones is one of those games, and it looks fantastic. It's a lot of fun. It's a lot of fun to play with frame gen. It's a lot of fun to play with multi-frame gen. It's a lot of fun to play with all of the ray tracing settings turned up as far as you can take it. But with the 5060 Ti, we basically got a did not finish result. You know, like from GTA 5's, like did not finish. It was just driver issues. It just ran out of time to try to deal with this. At 1080 high native, look at that. Look, we're doing great here. We're like 96 FPS, 73 FPS, 1% lows. You couldn't ask for anything better. That's pretty amazing. 1440p, we're just over 60 FPS, but our 1% lows are about 43. So, frame gen would be nice here. With FreeSync, I didn't really notice the frame dips like playing the games because it's a little bit cinematic. It's a little bit timing based, which I'm not really very good at. But if you want to like experience the movie, like it's a better experience than Indiana Jones and the Crystal Skull. Like, it's a better Indiana Jones story. It's a lot of fun. I'm still stuck at the part where I've got a floating screwdriver hand. I picked up a screwdriver and I died in Egypt, and I really don't want to. Like, the save system is so dumb in this game, and that really, I wish they would fix that. But that has nothing to do with the GPU. This GPU runs Indiana Jones and the Great Circle at reasonable visual fidelity settings shockingly well. I'll also say that for this particular game, our B850 results, I'll call those out, were surprisingly good, given how the B850 has, stacked up in the rest of this review. So overall, not too bad. Now, there's one standout at the far end of the spectrum, which is Doom Eternal and Doom the Dark Ages. On this card, it's like 50% better than the 5060 Ti in like-for-like settings. this card's just made to run Doom Eternal. It's a lot of fun. It's a really absurdly high frame rate game, and so that's a lot of fun to play Doom Eternal, and it's a lot of fun to play Doom Eternal at an absurdly high frame rate on an absurdly high refresh display. But again, just my subjective experiences. Doom Eternal is a lot of fun. Now, in case you're wondering about power, noise, and thermals, again, real-world gameplay, Indiana Jones. Take a look at Indiana Jones, the performance, and that sort of thing. So this is a little bit still game benchmarking, but also a little bit power. It's a single 8-pin connection on this card. It doesn't use a lot of power. And the heatsink is probably overkill. All the different versions of the Prime from ASUS, they all have different heat sinks under the shroud. More heat pipes, less heat pipes, different configurations. Your knowledge of other Prime cards may not apply here. There's only a couple of heat pipes. It's a very, I won't say very modest, but a somewhat modest cooler, but it is very effective. Even in a case like this. So like this is not an optimal cooling situation with like the fan flow through configuration here because it's sort of blowing into the power supply and the power supply is, sucking air in. It's not an optimal configuration in this tiny little small form factor case. And yet the GPU temperature peaks at around 70 degrees C and the hottest part of the memory around 80 degrees C. It's not hot at all, really. And even in Indiana Jones, a title that requires ray tracing, it's a pretty reasonable experience. The fans are basically inaudible over my air conditioner in this top of test bench configuration with the side on. You can't hear it at all. So overall, this card was competitive with the 5060 Ti in a lot of scenarios. Yeah, the 5060 Ti edges it out in a lot of scenarios, but this card can also be, 3 to 5 to 10% faster in a lot of games. You've got some standouts like Doom Eternal. Like, why is that one so much faster? Good job, AMD. But in terms of, will you have a good gameplay experience? Yes, in terms of the performance and everything else. You can build a small form factor machine. Like, what's this doing over here? You could actually theoretically build a gaming machine less than $1,000, assuming you can find these at retail for something close to $349, and build the entire rest of the system. And it doesn't need to be over the top insane. And you can still have a really amazing 1080p and 1440p gaming experience with ray tracing, which is, kind of a thing that you're entering into. I almost feel bad for the people that have 6,000 and 7,000 series AMD GPUs because ray tracing is becoming more of a thing in gaming and more of a thing where you turn it on and it's like, oh, the visual fidelity here is interesting and there's something going on. But these 9,000 series cards in general from AMD deliver significant uplift on the ray tracing side of things. So that's exciting. It's also exciting that if you can actually get these for $349, that you can build a gaming system again without spending thousands upon thousands of dollars. At the same time, if you're looking at building the highest of the high-end gaming machine, then okay, I think that if you're dead set on buying NVIDIA, it probably makes more sense in the $1,000 to $3,000 GPU budget scenario, because the cards that are farther down stack, depending on multi-frame gen, to pull the rabbit out of the hat, they're not doing it for me in terms of actual real world gameplay, unless I stick to much lower resolutions and lower visual fidelity settings, like the upscaling and DLSS4 and all those kinds of things. They're magical. Like, it is a magical experience on a 5090 with an OLED display like this. But most people don't have $2,000 to $3,000 to spend on a GPU, and you can get just as good of like a gameplay experience at 1080p or 1440p with a more reasonable card. I don't know that most gamers would find it worth the money to spend the extra thousands of dollars for the visual improvements when you could just save the money and then buy another new GPU in a couple of years. If you're doing AI and machine learning, you need something with lots of VRAM and all that kind of stuff. Okay, maybe. Speaking of which, this platform also improves AI and machine learning capabilities. It has something called sparsity, which changes the way that it handles floating point numbers to require less bits. And so if you're going to use AI on something like this, you should check out Amuse. That's something that has been tuned to work best with the RDNA architecture. There is ROCm for Windows and the ROC on GitHub, and there are things like that you can play with. I have the Procyon AI text generation benchmark, and the results for this card are a dramatic improvement over 7,000 series and prior generation AMD cards, but they still sort of bring up the rear. The 9,000 series cards still sort of bring up the rear in canned benchmarks from Procyon, like Procyon AI text generation score, and a number of tokens per second. It's not awful. It's not an unusable result. It's just that they're bringing up the rear, and this is something that needs work, and AMD knows that. So yeah, there you go. A $350 GPU is entirely reasonable, in my opinion. A good deal, fantastic deal, around $350 to $400, I think, in this market, especially all other things considered. And yeah, I don't know that for your average gamer, I really recommend spending more than $1,000 on a GPU. If you earn your living with it, if you're doing research, if you need it for reasons other than gaming, okay, yeah, sure, maybe you could talk me into that. If you have lots of disposable income and you just want to fart around with stuff, okay, yeah, you could talk me into doing something higher end than that. But at $350, 16 gigs of VRAM for future proof and having a generally good gameplay experience, at least for what I experienced, you could build a low cost machine that can run 60 FPS plus in all the AAA titles, and you can turn on FrameGen and drive a higher refresh display. And if you get a higher refresh display like this, more of your budget is going to go to your display than the actual machine. So yeah, that's the bottom line. I'm Wendell, this is Level 1. This has been a quick look at the 9060 XT. Stay tuned for more 9060 XT because we've got more 9060 XT coverage coming, and playing with that total board power wattage does make a little bit of a difference in those benchmarks in terms of performance and everything else. So stay tuned for that. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.